Okay, welcome everybody to the. I'm really excited to hear about code style. Maybe not the most exciting tutorial, but still really important. Okay, let's see if I can make this advance. Okay, why does code style matter? It's written once, it's read many times, modified many times, often not by the original creator. So, and software is a key part of the intellectual property now that most companies, even academic groups, etc., have. So, for that intellectual property to have value, because it takes a really long time to write, it has to be written so that we can actually maintain it, right? Other people can understand it, they can modify it, we can hand it over to other people. So, your goal is not just to write code that works, but code that is easy to read and to understand. And if you do go the other way, you write code that is hard to read. It's bug prone because it's difficult to reason about. It's hard to modify because people have to understand this code before they can modify it. And hence, it's challenging to reuse. And this often results in code getting thrown away, right? You might have code that could be modified to meet new requirements, but it's just too hard. Nobody knows how to do it. Everybody's too worried. So yeah, writing code in a good style is very important. So we're going to talk about a few guiding principles to keep in mind, and then a few more specific things. And these more specific things basically mirror what's on the M1 rubric. So an immediate reason to get good at code style is you'll be graded on it throughout this course. But beyond that, it is very important to your career. Because we'll talk about these all, but basically, how long should functions be? How should we name variables? Should we have a lot of temporaries or a few? Comments, what should we write in comments? How do we avoid duplicating code? How do we group data together into classes and structs, or should we do that? And then some good practices, like don't have warnings in your code, and a more advanced technique of how can you make your code check itself. So, and there's lots of aspects of code style that we're not going to cover, but these are kind of the core. Like, this is the most important stuff to do. Okay, so guiding principles. What are we trying to do when we write code? We're trying to reduce, and let me make sure I'm recording this. Okay, good. Okay, so we're trying to reduce cognitive load. So programming requires understanding a lot of details. And your brain is not that good at keeping a lot of details right in the front of your mind. So they've done experiments on this. Psychology practitioners, researchers have done experiments that come up with something called Miller's Law, that the human mind can keep about 7, that's the average, but there's some variation. So maybe 9 for some people, 5 for others, but a pretty small number of things right in the forefront of your short-term working memory. So what does that mean? You don't want to have people trying to remember 50 things all at once in order to make progress in modifying the code. Try to minimize how much they need to remember. And some ways of writing code help that. The other thing you want to be able to do is explain why. So if I can read the code, I can see what it does. If it's well written, I can see what it does without maybe undue effort. But I can't ask the original author, why did you do it this way? Is there a good reason? Is this limitation fundamental or just an accident? The original writer generally understood these assumptions and why things would be done this way, but you can't ask him or her now, right? Because they're not around. They left the company, they're off, not here today, and they forget too, actually. So I write comments in code I write, and I'll come back a year or two later, and I'm happy I wrote this comment because I forgot why I did it that way. And so I can recognize I wrote it, but I don't know exactly what I was thinking. So it's like a time capsule to myself. Okay, so now we'll get kind of into the details. How many people have ever taken code written by somebody else, like a significant amount of code, like at least hundreds of lines, and gone in and modified it? So some of you, how hard was it? Was it easy? Was it harder than you thought? Reading code is actually much harder than people think. We used to do something in this course, which we cut for time reasons, which was after milestone 1, we would give each team a different team's milestone 1 and have them write a code review, right? Like just a 1-page summary of what they liked and didn't like about the code. And what was interesting is even though they just completed the same assignment, so they know exactly, what the problem is and so on, they found it surprisingly hard to read the other team's code. And it's true. Code is much harder to read than you usually think. You're writing it, you go, I know exactly what I'm thinking. Somebody else doesn't. So these principles are to try to fight that, make code easier to read. Okay, so let's go through some examples of how we can do that. So let's start off with how do we write functions, how do we name our variables? So you want your functions to be pretty short. So at Google, Google has an extensive, most companies have a coding style guideline. Google has a pretty extensive one. You can look at it on the web. There's a link at the end of this presentation. Their rule of thumb is most functions should be 40 lines or less. Why? Long functions are harder to read because you've got to keep more information in your mind. There's more variables, more going on, and therefore harder to understand, harder to maintain. Shorter functions, on the other hand, they're basically giving names to parts of your code. You're saying this piece of code has this name, which should be meaningful, should tell you what it does, and it gives hierarchy to your code, right? You have like an overall control routine calling helper routines, all of which have good names. I can read the control routine to get the bigger picture, and then if I need to, I can dive into the detailed routines. If I wrote one big routine, I got to keep more in my mind, and I can't get that big picture so easily. How do we get long functions? Sometimes people write them right away long, which is bad, but often they also grow over time. So the function might have been less than 40 lines to begin with, but you're hitting more cases, you're putting more functionality in, so you just need to add a couple lines here, a couple lines there, and gradually it gets longer and longer. This happens all the time, so what you have to do is when it's getting too big, you need to refactor it. And refactor just means edit, like revise, redo. So you would go in and you would say, okay, I'm gonna look for some logical places where I can make helper functions, I'm gonna make this shorter again, and it'll now be easier to read. The tendency of code as you write it is that it gradually, entropy increases, right? As you're fixing bugs, the code is aging, it tends to get more chaotic. And you have to fight that by basically putting aside some time to refactor code. You're gonna go in and you're gonna clean it up. Okay, variable names. So good variable names described, you can read the name of the variable and you have a pretty good idea of what this is used for. I don't have to go back and look at its declaration and read the comment there or trace through exactly what you did from it to it. Like I can get at least a pretty good idea of what it's for just from its name. To minimize this cognitive load, you also want to minimize the scope of your variables. So for example, this is why you don't put global variables all over a program, because now you have all these variables to remember because they could be changed anywhere. So undisciplined use of large numbers of global variables is bad. You are using them in milestone 1, but you're using it in a more disciplined way. On a smaller scale, though, this can also happen in functions. I'm going to show you a few different ways you can declare your variables, and some of them you just don't have to, as you're reading a function, it just doesn't have as many live variables, like variables that are in scope that you have to keep track of. Temporaries. So I'm going to show you a few different ways, snippets of code, and you can decide how many temporary variables do you want. So sometimes temporary variables can help readability because the name of the temporary tells you, okay, this calculation was doing something, I store it in a variable with a very meaningful name, it helps me read the code. But if I have a lot of temporaries that are almost just renaming variables, like it's kind of just this temporary is a copy of that variable, that actually makes it harder to understand the code because I just have more variables flying around. So they're kind of a balancing act. It's sort of like when you're writing an English essay, you shouldn't have all short sentences, you shouldn't have all long sentences, you have to look at temporaries case by case. So there are some basic naming conventions. So you want to make your variables descriptive, that means they're usually going to be multiple words. So there's 2 common conventions, something called snake case is you put underscores between the words, that's fine. Or something called camel case is you capitalize the start of every word after the first. Pick one, doesn't matter, we don't really care very much, they're both fine. If your team picks one versus the other, your code will look a little more uniform. On the other hand, it's not a big deal if different team members do different things in different functions. We're not going to be super picky on it. We do want to see like sort of longer, more meaningful variable names. So you're probably going to use one of these 2 things. 2 common conventions for constants. So it's good to name your constants so you can immediately tell they're not really a variable, they don't change. So some people start them with a K to mean constant, and some people start them with, or make them all uppercase. Either one works fine, so you can pick one of those things. And then another good convention is that types and class names. So when you define a struct, you define a class, you have a type def, these are all defining types. And to make them clear that this is a type and not a variable, a good convention is to start it with a capital letter. And you notice that these variables do not start with capital letters. So I'd recommend those basic conventions. Okay, so now let's look at some code to see, well, what do you think of this stuff? So here is some code for actually one of the functions you have to write, find street segment length. And we pass in the ID of a street segment index. And this doesn't even show all the code. Basically, there are two important cases. There's what if I have curve points and what if I don't? And what I'm showing here is just the code if I don't have any curve points. And this code works, okay? There's no bugs in it. If you love it, and you're not done milestone 1, you can take that, you can put it in part of your project. And then there's gonna be more code down here to handle the case with curve points. What do you think of this code? Do you like its style? Do you hate its style? Any thoughts? I see what do you not like in it? Okay, what do you not like about it? Yeah, so there's no comments, so it's going to fail our comment test. Totally true. We're going to get to that in a while. And I also agree with you, no vertical space. Vertical space is kind of like paragraphs in writing. The lines are like sentences. The vertical space can break things up into paragraphs. This person didn't do any of that. So it's a bit harder to read because of that. So use vertical space intelligently. Yeah, what do you think? Right, so you think these temporaries are not very useful, right? Like, so I did a temporary, but I didn't do much work. I just took the street segment info.from and gave it a new name. And then, and then I just used it once. So in your opinion, this temporary is kind of reducing readability. Like if you had just done the work in one line, it would be easier to read. I agree with you. This temporary seems kind of excessive. So any other thoughts on this one? Where are the variables? Yeah, go ahead. You say just a little louder. Right, so I was going to repeat that for the recordings. You're saying, well, you declare a lot of variables way up here, right? And you don't actually use them. In fact, a bunch of these dist functions are only used way down here in the else clause. We didn't even use them in the whole if part. So why did we declare them and initialize them to 0 so far away from where we needed to use them? Because we're kind of increasing the cognitive load. I'm reading this code from top to bottom. There's all these variables being declared. I have to try to keep them in my mind, watch that they're not getting changed anywhere. But in fact, we're not even going to use them for a long time. So I could have made this easier to read and less bug prone if I didn't declare them so early. So yeah, so these are all really good ideas. So let's go through and try to clean it up a bit. So horizontally, it's indented properly, and make sure you do that. Like not indenting is like writing an English essay where you didn't use capitals at the start of the sentence and you have no commas and no periods, right? Like it's far, far, far below expectations. So you should obviously always have proper indentation. But this lack of vertical white space also looks harder to read. So if we break it up a bit, I would say this is easier to read. Okay, so we don't want to put a blank line after every single line. That's just double spacing it. But I can see the if statement. I can sort of see the steps because I sometimes have two lines that are very closely related. So this is a bit easier to read just by putting in white space vertically. This is what you just commented on. Lots of function scope variables. So we're declaring things at the top of the function. We're not using them for a long time. Some of them we never use in either the if or the else. So we can move those. So length, for example, we use way down here, okay? And these other variables, these distance ones, we don't even use in the if, we only use here. So we don't need these variables to be declared so early. Why do people do this sometimes? I think part of it is the original versions of C, you had to do this. So, but no modern version of C or C++ limits you this way. And most other languages don't limit you this way either. So you can now declare variables wherever you want. So what we should do is try to declare variables at the smallest scope we can. So what does that mean? It means we don't declare we don't declare any of these variables way up at the start of the function. We're going to declare double or declare lengths right here, right before we use it. We got rid of the initialize to 0 because we don't actually need that. That was just, it's not clear why we initialize it to 0. We can just set it to the right value right away. And those other variables are basically gone from our if. They'd be pushed down to this else clause, so they're easier to see. What about this? So we declare length now, so it's better. We declare it right where we use it, but we declare length and then we immediately return it. So is this a useful temporary or not? What do you think? Doesn't look super useful. People are shaking their heads. So yeah, I'm going to get to this in a minute, but probably we could just get rid of, we could collapse these two lines into one line and just return this value. Neither one's super hard to read, but it's probably a bit more succinct, a bit easier to read if we just directly return the value. You also flag this, the variable names. Well, we don't need all these temporaries, so that's a good point. Also, our variable names could probably be a bit better. So inter1 and inter2, we've lost the fact that one of these was the from intersection, one is the to intersection. That was in our original name, and we kind of lost it in our temporary. And that's actually kind of important when we get into curve forms. So losing that information is maybe not the best. And we have a lot of temporaries here. So let's try rewriting this a bit. Okay, oh, and then an even worse variable name is this, ID. Okay, it is an ID, so it's not like a misleading name, but we have a lot of IDs floating around in our program. And so this ID would be better if we actually used a more meaningful name like street seg ID. Okay, so now the name of the variable immediately tells me what should this refer to. So I'm going to rename that one. We have another name that's not great, info. Okay, it's not the worst name, but doesn't tell me much. Like info's, if you have variables named data, info, control, these are not good names, right? They're not telling me much. So we can change that just to seg info. It's a little more meaningful. But now here we're going to get rid of this temporary. Okay, so you flag that these lines seem kind of not to do much work. Let's try getting rid of that temporary. So we just moved this seg info.from and to into this line. So which of these do you like better? Do you like this one where we have those temporaries, or do you like this one where we got rid of them? What do you think? Who likes this version better? Okay, so say that most people like it better. Yeah, I like it better too. It's shorter and it's not hard to read. So now these names say lat long 1, lat long 2. So we're losing which one is the from and to. So we could rename this to pause from, pause to. Is this a better name than what we had? So we had lat long 1, lat long 2. Now we have pause from, pause to. What do you think? I'd say it's better in one way. We can tell what's from and to, but we lost the fact that these are latitudes and longitudes. And in your program, you're going to find you often have lat long and you often have xy where you've mapped it to the surface of the Earth. So I think an even better name would have been lat long from, lat long to, or LL from, LL to, because each of these names has kind of lost a bit of information, and we could have chosen a smarter one. You can tell. So you're right. I mean, I could tell on this line what it is because it's declared there, and later on I could look at this variable. I can look back to where it was declared, and I can see what is it. So I can figure it out. If I'm in an IDE and its IntelliSense is working, which is questionable sometimes for VS Code, it would also, if I hovered over it, it would show me its type. So I can figure it out. So you don't always have to embed the type in the name because you can figure it out. But I'd say here, instead of calling it pause, I could have just called it LL or lat long. It's not really any, LL's shorter, lat long's marginally longer, and it immediately tells me what it is. And if all we were dealing with for positions in this program was lat longs, then I'd say it doesn't matter, right? Because everybody's going to know what I mean by pause. But you are going to wind up with two different kinds of positions, right? Those in latitude and longitude coordinates and those in meters on the surface of the Earth. And I find it easier to just establish a convention. So I'll use lat long or LL to mean this is in latitude, longitude, and I'll use X and Y That's part of the variable name to say this is on the surface of the Earth. And now there's less room for confusion. Does that make sense? Okay, but so name is maybe better, maybe not better. It's not the best possibly. Okay, so I can also eliminate this temporary, right? I'm calculating length and then I'm immediately returning it. So I can just get rid of that. I can just return find distance between these 2 points. And this looks quite a bit better than what we started with. And I can keep going, right? I could say, well, these temporaries, instead of using them, I could just paste in, how I got them. So I could write this, if I want to, I can put the whole, what's in the if, into a single statement, right? So return find distance between 2 points, and these are the 2 points. Get intersection position of the from and the to. So do you like this better, or do you like this better? What do you think? Okay, so there's one line, or one statement, or I can have a couple of temporaries. So who likes one statement? There's one statement. Okay, so at least one person likes it. Who likes having a couple temporaries in this case? Most people. Yeah, so I actually, there's no right or wrong here. So don't worry if you're like, wait, I said I like the one statement, it's fine. I personally like this one better because as I eliminate that many temporaries, I find I kind of have to read this from the inside out now. I have to go, wait, okay, this cognitive load is kind of going up for me. I have to remember I've got the from intersection. I'm doing this lookup. Okay, so I've got the ID of the intersection. I look up what's its position. I do that as well for the 2. And then those are 2 lat longs, and then I pass them into this find distance functions. Okay, I know what it does. For me, when it's that much work on one line, I find it harder to read because I kind of have to read it from the inside out and keep track of what's going on. So here I find that this number of temporaries helps me a bit, right? I can keep this much in my mind, and I kind of like the variable names to help me along. The other reason I like this is if I'm running it in the debugger, I can hover my cursor over these or type their names into the watch window, and I can see what these variables are. So I can single step over them. I can see their computation. And in this style of code, I kind of have to step inside the functions, see what is being computed and what they're about to return. So it's a little more difficult to single step. You can still do it, but you kind of got to pay careful attention because you don't have so many variables visible where you can just step over the lines. So I personally wouldn't write, this much on one line. But one of my TAs who helped make this tutorial believed this was the best code. Okay, so there's differences of opinion. So he initially just said, yeah, it's the best. And I put in maybe it's better, maybe it's worse. So there are differences of opinion when you get into the details of this. Okay, so this is what our code looked like before. Works fine, properly formatted horizontally. But after we've done all this is what it looks like after. And I think you'd agree, this is actually quite a bit easier to read. It's nicer vertical spacing, we have better variable names, we eliminated some temporaries, some early declarations. The code is actually shorter, but actually has better naming conventions, so it is easier to read. So what do you think? Do you guys agree? So that's the way you should write your code. Like that's what you're striving for. Okay, comments. Okay, so I guess the first thing about comments is almost all programmers don't comment enough, right? It's very rare that somebody comments too much. Most people don't comment enough. When I was at Altera, we would do code reviews across all the code that my team wrote. So we pick modules and have like code reviews of 5 people who review maybe 1,000 lines of code to give feedback to the main author. And part of the way we would pick what code to review is I'd just write scripts to go look for code that had less than 25% comments. So if less than 25% of the lines were comments, probably this code is not in great shape. And that proved to be a pretty reasonable heuristic, right? So you want quite a few comments in your code. And then some comments are more important than others. So let's talk about which ones are most important. There are a few different places where you comment your code. So if you look in the files we've given you, this is at the top of the libstreet database API, okay? And it describes what is this API and what kind of things are you going to find in this whole file. Then you're also going to find in that same header file that above every single function, we've put a comment saying, what does it do? Okay, so file level comments, function level comments. Whenever we define a new data type, so a structure or a class, we also comment that. So this is the street segment info struct. And there's a comment saying, what is this for? And then we also commented exactly what is every single data member. And this one is just packaging together data, so it doesn't have any functions, right? No function members. If it did, we'd comment those too. And then I haven't shown you this, but basically you're going to find in your code, in any code, that you'll have some comments above blocks of code. Okay, so here's a comment that says we're going to compute the sum of an array over all its elements. So it's just saying, what does this block of code do? Okay, so 4 different kinds of comments. Do you have any opinions about which of these are more or less important? What do you think? They're all important? They're all useful. Yeah, so this is not most people don't comment enough, so don't take this as like, hey, there's one most important, never write the other kind. Not true. So they all are useful, they're all important. But if I told you I'm going to put somebody on your team who is bad at commenting, and I just can't make them write all the comments, which ones would you say? Well, try to prioritize those ones. What do you think? Okay, so you say high level, you say function, is that right? And yeah, this is one where there's no absolute answer. So I would say the high level comments are the hardest to figure out. Like if someone, so the code, this one, in my opinion, is the least important. Not bad to have. And this particular comment is actually pretty simple. So this one is not very useful. It just says add up the sum, make a sum of the array by going all the elements. So it's telling what the code block does. It's actually pretty obvious what the code block does. So it's not even giving me much big picture. So the low-level comments are less valuable than the big picture comments because you can usually figure them out by reading the code. What is the whole purpose of this file and this API is quite important, like for 2 reasons. Should I actually read this file, right? So if somebody's reading your code, maybe this is the totally wrong spot to be reading for what he or she's trying to do. Also, if I'm going to extend your code, is this the right file to put something in? What belongs here? Overall methods by which it works. So that's really important. It's hard to figure out. You may have to read a lot of code to try to figure that out. So there's another story from my early days at Altera. So we were acquired, actually this is before we were acquired by Altera. So it's still a separate company. We're working, Altera is one of our customers. And there was one particular question I had about how their CAD system treated a certain detail of their chip because we found we had to duplicate it or else their tools wouldn't accept our answers. I only had, so it was literally one question. And the answer was in like this file that they sent me. Okay, we'll show you how we do that. It was uncommented. There was no comments. It was 5,000 lines of C++ code. I spent all day reading it. It's actually not bad. I was reasonably proud that I could figure out 5,000 lines of C++ code I've never read before by reading it, but it did take me like 8 hours. And then I could answer the question. This is a very specific question. If this person had put a comment in saying, what the heck am I doing? I could have done this in like 4 minutes, right? So you can lose a lot by not having the high level insight. Function ones are also important. Okay, so this is now documenting a little lower level, but it's still pretty important. You put them in a header file because you put the function about what does the comments about what a function does in the header file because you want people using it to be able to see this is its purpose, right? You're documenting the interface. If you put the comments just above the function declaration, then most IDEs, or maybe all IDEs, will actually show that when you're just browsing the code. You hover your cursor over the fact that you're going to call this function, and it'll tell you what it does. So it's helpful. Class, this is very important. If you can't figure out a program's data, it's really hard to figure it out. So I'd say this is probably, in my opinion, I'd probably say this is the most important because it's the highest level comment. And I'd say this is the second most important because if I can't figure out the data of a program, it's very hard for me to figure out the functions and how to modify anything. So any classes, tell me what they are, and then tell me very precisely what every data member needs. And then I'd say the functions, which are also important, and then I would say code block is fourth. And you could disagree on the details of this, but I guess the high-level comment, the high-level point I'm trying to make is that the comments that often people are least likely to write, like the big picture comments, are the most important, right? The hardest ones for you to figure out after the fact. Okay, so top of files, classes, where you declare your functions, so in the .h file, so you're telling people how to use it, and they don't have to read the .cpp file. And then least important, but still good to do, explain tricky code. You know, maybe a long, more complicated function inside it might explain how it works, but it's not as important as the other ones. You don't want to leave commented out code in your project. So often people write code, it doesn't work, they decide, okay, I won't do that, I'll do it a better way, but I'll leave in the old code. You can do that the day you're working on this, right? Because you're not quite sure, maybe I'm going to tweak it some more. But once you've decided, no, I'm not using that code, delete it. Don't just comment it out, because you don't want people for all eternity to be reading through your commented code, asking why is this here, right? Should I try to resurrect this? It's in the way. Git has all your code. If you committed it, that code's still there. If somebody really needs it, they can go back and get it. You also don't want to write comments that translate, kind of obvious code to English. If someone is reading your code and they don't know the programming language you're using, they are doomed, right? There's no possible way you can explain what a for loop does, etc. So just don't do that. Okay, so next thing, duplicate code. So don't duplicate code. You use helper functions to avoid writing the same code multiple times. The reason you don't want duplicate code is, well, you can extract it in its own function, which improves readability, makes it more reusable, and it avoids a common source of bugs. The alternative to making a helper function is usually taking a block of code and copying it multiple times and changing the variables, and that's error prone. When people do that, they sometimes forget to change some of the variables, and then if you later find a bug in that block of code, you have maybe 20 places to go change it instead of like one helper function. Okay, so this is another piece of a milestone one function. It's actually the one that we wrote in tutorial 3 and debugged in tutorial 4, but it's a piece of writing it in a different way. So we're trying to load up that global variable, a 2D vector of intersection street segments. Okay, so what street segments go with every intersection? In tutorial 3, we wrote that by looping over all of the intersections and then making API calls that way. Here, I'm just doing it a different way. I'm looping over all the street segments, and every street segment knows, so SS is a street segment, every street segment knows what intersection is on its from end, and it knows what intersection is on its to end, okay? So different way of coding this. What I'm doing is I'm basically getting the from intersection of a street segment. I am checking, is the street segment that let's see, let me read this carefully. This one, okay, so what I'm doing is I'm calling this STL templated function called find, okay, so it's called an STL algorithm, and it takes a few arguments. It takes the start of a container, well, it takes 2 iterators. So I'm passing at the start of my vector of street segments for this intersection, and I'm passing at the end. So I'm saying search through this whole vector that has all the intersections I've found for the street segment so far, and I want you to look for the street segment ID that I'm currently processing, right? Because I'm looping over all the street segment IDs. And it returns an iterator. If that iterator that you returned is equal to the end iterator, it means that this street segment is not in that vector, okay? So I've never put it in there. So what I want to do now is I want to add it. Okay, so I add it with pushback. So this basically does the same thing as what we did in tutorial 3, but probably in a little bit less clear way, right? We just run through all the street segments, find their intersections, and if we don't have the street segment in the appropriate vector yet, we put it in. Does this make sense? Okay, so that's what the code does. The street segment has 2 intersections, a from and a to, so I do it twice. So if you look at this code, you're going to see it's basically the same as this code. Okay, it is duplicate code. Do this for the from intersection, then do it again for the to intersection. And I said this is bad. Like, does it look bad? right? Do you like this duplicate code and figure out it's fine? Or does it make you feel sad, right? Like, I want to get rid of it. Okay, so it should make you feel a bit sad. So whenever you see duplicate code like this, you should be thinking helper function, right? Code will be shorter, code will be easier to read. So the helper function that we can extract is basically this. Because if you look at this block of code, like, what convinces you that there's likely helper function? And sometimes you don't see it at first. You know, you might write code and it's duplicate. Sometimes you can see the helper function you need right away, so you write it in advance. Sometimes you don't, so you find I'm duplicating this block of code, and that's where you refactor. You go, this code looks just like this code. What's different between those blocks? That's the first time we ask that. How are these two pieces of code are very similar. What's different about them? If they're exactly the same, then I shouldn't write it twice, right? So they're not exactly the same, but there's a little bit of difference. What's changed? Yeah. Yeah, so I've changed from the from intersection to SS2, the to intersection. Otherwise, I'm just doing the same thing. So that's how you find helper functions after the fact. You realize this code is the same. Now, there's actually a bug in here. So yeah, if you can see the bug, I'm going to give you a chocolate bar. So, right, so this is actually the bug that I told you about that is very common. You know, we take this code, we copy it, and we're thinking, well, we're going to do the same thing again. Everywhere we had SS from up here, just do the same thing again, but for 2. And we actually remembered to change that 3 times. We missed the last one. This one's still from. So that's a copy and paste error. This doesn't make any sense, right? It doesn't make any sense to be doing all these checks for the to intersection and then add the new street segment into the from intersection again. So, but it's actually hard to see. So you have good eyes, you saw it right away. When you look at this code, it's a subtle bug, right? Visually, it doesn't stand out. So don't do this. Okay, so we should extract it into a function. So we basically have this block of code, and we put it in a function. We should give it a meaningful name, and the name helps us organize our thoughts. So I'm going to call it insert unique, because that's what that function was doing. We were checking, is the street segment ID in the vector? And if it's not, we insert it. So we can make a function that just does that whole thing. It has a nice name, and it actually makes it easier to read. Like I explained to you what that block of code was doing. Now that we've put it in the function name tells me what it's doing. So, okay, so this is better. What do you think about these comments? So I've got 2 comments here, right? One comment here, and then another comment here. Okay, so what do you think about those comments? You like them, not like them? You change anything? Yeah. Yeah, the comment basically says the same thing. All we did is change SS from to SS2. So what would you change? Yeah, and that's exactly what the next slide does, because it is better, right? So we've kind of put the 2 lines of code together. It makes kind of a paragraph. These are highly related. We put one comment above it. Add street segments, not a duplicate, and it's easier, right? We moved our comment to a little bit higher level. We're not saying, what does this one line of code do? We're saying, what does this block of code do? Higher level comments are more useful. We could probably still make this better, because this says added if it's not a duplicate. It doesn't say why. So unless there are comments above that would make clear why we don't want duplicates, probably would be a good idea to say, because the spec says no duplicates or something. Like, why did we do this? Okay, so I'm going to do a quick demo, and then we'll take a break for a few minutes. Can you guys read that okay, or should I make this one bigger? Maybe I should make it one bigger. It looks a little small to me. Let's see if I can shrink this down too. How's that? Can you read that, or it's fine? Okay. And maybe I can get rid of this. Okay, so this is m1.cpp. Let me get rid of this too, so I get a little more real estate. Okay, so this is the milestone 1.cpp files that I showed you last week in tutorial 4. I've stubbed out all the functions except one, and the function I didn't stub out is the one that we debugged last week. Okay, so it's this function, find street segment of intersection, and it has a comment. Okay, so the header file already had a comment about what this does. I don't need to repeat that here. This says that it's an order 1 function, and you should make sure that this global variable I'm using is loaded before you call me. So I'd say this is pretty well commented, right? Like the header file says what it does, and they actually put in how fast it is, and there's something you got to watch for in terms of calling convention. Make sure this is loaded. So I'd say this function is pretty good. But then let's look at load map. Okay, so to make this fast, remember that we had to move a bunch of code into load map. So here's my load map. It loads up the loads up the streets database, our API, and then it goes through all the intersections. Well, it makes a vector size of all the intersections. It goes through all the intersections, getting the street segments, loading up the second dimension of the vector. So you know what this does. What do you think about the style of this? So you think down? Yes, your TA is going to do that too, right? Your TA is going to go, whoa, this is like, how low can I take this mark for style? Okay, so don't write code like this. What's wrong with it? It's not commented. Right, so I should put a comment on it. I'm not going to do that right now, but you're right, it should be commented. What other things should we do? There's lots of things wrong with this. So what other things should we change in the style? Yeah, it has no spacing of any type, right? It is indented, so I guess it's indented, but it's pretty hard to read because I didn't put spaces around any of the operators, and there's no vertical space. And it's also kind of odd. This is an odd convention of putting what the if statement does on the same line as the condition. Okay, hard to read. So I'd say this is not very well formatted to begin with. So I could go in and fix this by hand, but you can also just highlight a block of text and just say format selection. So I do that, and the formatting looks much better. Okay, so you can do that on a whole file if you want. So it's put spaces around the operators. It's put in, it hasn't put any vertical space in, but it looks a lot better. I personally don't like putting this bracket underneath. I like putting it up there. So I'm just going to go in and change that. Let's see, do this one too. So I changed it a little bit to match my formatting preferences, but this still can save you a fair amount of time. Every year we'll get a few teams where the workload's really unbalanced, and if it continues, eventually sometimes I get involved talking to the team, and some years we'll have like commits from one team member who's not doing much that says he reformatted the code, right? You'll have like commit after commit saying reformatting code, reformatting code. Okay, I just showed you how hard it is to reformat code. So you should not make that your only commit is that you're reformatting code, because your teammates could do it in about 30 seconds if they selected the whole file. So do more. Okay, so this is better. I've cleaned up the spacing. Is there anything else I should do? Should put a comment in. What else? Or is it as good as it gets? Yeah. Yeah, these names are not very good. Okay, so I told you it's really easy to get confused about IDs. So, this is a person who is a big fan of one character variable names. So we've got I, we've got X, we've got J. These are not very meaningful names. So let's take I. What would be a better name for I? There are lots of better names for I. Okay, I is as short as it gets. So, what do you think? You got an idea?
It's looking for the intersections, right? So
yeah. So you call this intersection index, intersection ID. Either one would work fine. Okay, so I could go through and I could find everywhere I used I in this loop, like every I that corresponds to this variable. But I can actually be smarter. I can say right-click and I can go rename symbol. Okay, so it's currently I can change it to intersection you want index, right? Intersection IDX, I hit enter, and they're all changed, okay? Okay, so I just selected the variable. So we're gonna do it again. I'm gonna do it for X, okay? So this is smarter than just to find and replace, because obviously there are a lot of I's in this file. If I just said change every I to intersection IDX, you know, I would get I's all over the place. Like in the middle of other words, it would be chaos. So I don't wanna do that. What I did is I just selected the variable. So I just left clicked and highlighted it. And then I right clicked to bring up the, you know, the menu of what can I do right now, right? And I said, well, let's rename this symbol. Sorry, do you have a question? Go ahead.
If you have multiple like eyes, would it change like every single like time?
No, so it's smart. It actually understands the context. So it knows the scope of that variable. So it's changing that variable name. So it doesn't change I if it's in the middle of another variable name, but it also doesn't even change I if it's in another variable. If this variable is scoped to this way. If this variable is scoped to the whole function, then it would change every I in the function. And if it was a global variable, okay, then it would change it everywhere. But then if you have named a global variable I, like your TA will be dead, right? Your TA will have a heart attack, and you know, whoever his or her successor is will then give you a 0 on code style. Okay, so don't do that. Okay, so I'll do that again. So I basically just highlighted that by left clicking on it. Whoops. And okay, let me try it again. Okay, so you just left click and drag, you right click, and let's rename this symbol. Okay, so what is X? X is a really bad name too. So what should we call X? No, maybe not Y. Okay, so we're calling get num intersection street segment. Okay, so what is X? Yeah, it's basically not the number in the whole, it's the number for this intersection, right? How many street segments hit it? So there's lots of ways we could do that. I mean, I like to start integer variables with I or N. You don't have to do that. So I'm going to call this maybe num6 or num, how about I call it num street6? Okay. Okay, and it went off and it changed the X everywhere to that. And this num is kind of bad, okay? So let's change, what would you change num to? Okay, num is not a great value. I can be more specific to that. What is, this is the number of what? Yeah, this is the number of intersections, so I'm just gonna change that. Okay, and this J is pretty bad. Okay, so I'm just highlighting it, right clicking, going rename symbol. So this is from J equals 0, J less than num street segs. Okay, this is a small counter, right? This is just gonna go over how many street segments are connected. But I probably could still give it a better name, like maybe iseg. Okay, so at least it tells me, or I street seg. Okay, so what is the, or maybe I'll call it street seg. Yeah, I don't know what, this one is a little harder to name because it's kind of like just a loop counter. So maybe I'll call it iseg count or something, okay? And I don't know, I can't really do better than that, I think, for this one, because it's just a small loop counter. But I think this is a lot easier to read. Would you agree this is now easier to read? Okay, sounds good. Yeah.
Do you think it's worth instead of using ints, using intersection idea for like the other types?
Yeah, you could do that too, and it would probably be a bit better. So I just called these ints, and that'll work fine. But I could make this probably a little more explicit still by changing it to intersection index, and that's arguably better, right? You're kind of being a little more explicit still. Okay, so I'd say the style's a lot better. Anything else you think we should change? Well, let me give you a hint on this one. Okay, this is load map. Right now, load map looks fine. Okay, so it's not very long. You know, that's maybe 15 lines of code or 20 lines of code. It's not bad. What you're going to find in your load map is it does a lot of work. It's going to load a bunch of different data structures, So by the time, I've only done the first function. By the time I'm done, this could easily be a couple hundred lines of code. And that would make the TA sad, right? Because it's a long function, and it's fairly linear, which is better. We have a long function, one that goes in a straight line is better than one that has lots of loopbacks, but it's still a bit annoying. So I would say it's right now, it's better to extract this to a helper function. If I didn't notice and load map got big, well, I could go extract things to the helper functions later. Now, VS Code doesn't have a function to do this. So I'm going to open up NetBeans. Let me save this so it goes to disk. Okay, so right now this was just, a few students have been confused by this, just in the editor. I just hit Control S to make sure it actually goes out to disk. And now I'm going to open up a different IDE. Okay, so I'm going to open up NetBeans. IDEs are just, smart text editors and a way to invoke the debugger, so you can run different IDEs on your code if you want. And I've already opened up this project in it. So let's go to, okay, so it's in libstreetmap source m1.cpp. Okay, it's the same file I was just showing you. And actually, you know what I'm going to do? This is probably not visible. I'm just going to start this again. But I'm going to tell NetBeans to use larger fonts. So I've made something called an alias that starts NetBeans with a command line option to make the fonts bigger. So, okay, so this is my m1.cpp file in my libstreetmap. Let's get rid of this output. Okay, and you see it's just the same code, right? So nothing magic about IDEs at all. What I'd like to pull into helper function is this. Okay, so this part, oh, this actually still doesn't match my formatting convention. Let's do that. All right, so this whole part here is basically doing the loading of that one data structure, intersection street segments, right? What comes before is load in our low-level data, and then in the end return that we had success. But all of this really can be a helper function. So I just highlighted it. I right-clicked, and I say refactor, and I can say introduce function. Okay, and this pops up this window, and I give it a name. So a good name for this might be load intersection street segments, right? That's the name of the global variable I'm loading. I can, and let's see, what is that doing? I don't want to pass anything into it. So why is it passing something into it? I'm going to put a, so I want to get rid of that. Okay, so right now it wants to pass num intersections into it. I don't want to do that. I don't want to pass anything into it. And I say refactor, and it's basically done it. Okay, so you can see right now it's changed all those lines of code. I didn't pay attention to my num intersections, so I don't want that. But it basically has pulled all of that out into a separate function. Okay, and it's called it for me from this point. And let me do this one more time really quickly. So I'm going to undo it. And I think it's basically, I take this whole section, it's now probably not going to want to have intersection index. Interesting. Okay, so I want to get rid of those. And I want to call this load intersection index, preview it. Okay, so it keeps what I did this on Wednesday, and it understood I don't want any parameters going into it. This time it keeps wanting to put in a parameter, but it's still helpful with refactor. So most IDEs like NetBeans and CLime have this function that you can pull out helper functions automatically if you want. So if you want to speed up doing that, you can open up one of those IDEs. Visual Studio Code just doesn't appear to have that feature. Okay, So that's it. We'll take a break. Basically, my whole point showing that is IDEs can help you do this, right? You've written your code, they can reformat it, they can change variables, they can even help you pull out helper functions because refactor is such a common operation. So let's come back at 4:16, okay? And then finish the tutorial. Okay, we're back. So a few more code style things. Okay, so does everybody know what a magic number is? It's saying don't use magic numbers. What is a magic number? It's like the magic word. Just put a comment in saying please, right? Please work. What do you think? What's a magic number? Oh, okay, that's probably a mathematical magic number. So that might actually be a more precise one, but in coding that it doesn't quite mean that. So yeah, what do you think?
For example, like -100 if you're expecting a positive value.
Yeah, so let's think -100. Well, maybe you use -100 in your program to mean something's gone horribly wrong. Okay, so if my function is supposed to compute the area, and if it gets completely confused, it returns -100. That's called a magic number, right? Because that -100 you might now use multiple places in your program. You're checking if the area was -100. It's not clear what you meant. It's not clear why is -100. It's not clear if I want to change it. Do I change every -100 in the program or change some of them? What do I do? So it's a bad practice. So here's some code that uses magic numbers. Okay, so this code doesn't do anything super interesting, but it's basically a function that gets passed an array with 20 numbers in it, and it goes through them, and it basically checks, if it finds a negative number, it returns -1. If it finds a number that's 0, it returns 0. And if it goes through the whole thing and didn't find any negative numbers, didn't find any zeros, it returns 1. Okay? Why do we do that? I don't know. What are the magic numbers in here? Actually, there are a few magic numbers, but what would be counted as a magic number? You'll notice on the M1 rubric, it says, do you have magic numbers? So if you have them, you get a little bit of stall marks taken off. So what are the magic numbers here? What do you think? Yes, I will give you a chocolate bar. So negative, so you think this -1 is a magic number? Yeah, it is. Any other magic numbers here? What do you think? Yeah, and he already negotiated a chocolate bar for you. Because to be fair, I got to give you a chocolate bar now too. So well done. Yeah, 20 is a magic number. 20 is even worse, to be honest, because we're using it in 2 spots. So if I ever decide I want to make this array have 40 numbers in it for some reason, I actually have to remember to change it in 2 places. That's a common programming bug. I might remember to change it in one, but not the other. I might decide it's all over the place. So I might globally search and replace to change all the 20s. But maybe there's another one that really shouldn't have been changed. So it's bad. And there's a couple of other ones here. I also return 0 and I return 1. So this is the worst magic number. Okay, I made an size of an array and I just hard-coded it to some number. That's really bad. But these return values, I mean, I could comment them. That's going to help, right? So -1 means I found a negative, 0 means I found a 0, and 1 means I didn't find either of those things. So a comment would help, but it's still not the best, right? I'm going to have other parts of the code checking if this returns 0 and -1. So it's better to use named constants. So named constants just means I still want those constants, but I'm going to give them a name. And C++ has multiple ways to create named constants. So probably the most basic one is you just put the word const in front of some variable, which means it can never be changed. And this is just as efficient, basically, as using the actual number. The compiler can go, oh, okay, that's a constant. I'll just replace it when I'm compiling by a 20. But it's much easier to read because we've given a name to this, num weights. We've set it equal to 20. If I ever wanted to change the size of this array, I change it in one spot, right? If I need to make it 40, I just change that to 40, and it's for sure going to change it everywhere. There are other ways to make constants in C++. So this is making what's called an enumerated type. An enumerated type is basically, I'm going to define a type which is just nicknames for certain integers. That's what enumerator means. It's really an integer, but I'm going to give nicknames to some of the integer values because I'm using them as status codes. So I've said has neg is -1, has 0 is 0, and all pos is 1. Okay, so the code that gets generated is identical to what would happen if I just used -1 and 0 and so on as my return values, but it's easier to read. Now you see has neg, has 0, all pos. Should still comment my function, but to be honest now, the function is a lot easier to read because these return codes are kind of self-documenting. And then there's a third way I can make constants, slightly older way. C++, the first thing it does when it's compiling is it runs something called the preprocessor, which is basically like a text substitutor. So it would basically, wherever it sees, with that hashtag define, weight 0, to be 0, basically the first step of compilation will literally just go through and everywhere it sees the word weight 0, it'll put a 0 in. So it also works. It's probably a slightly older style way to make constants. So probably most people will do it that way, but all three of these work. This enumerated type is also a bit nice because I can basically use it as the return type of my function. And that's just giving a little more information to the person reading the code that this should only return certain integers, the ones that I've given names to. I should never return some arbitrary integer. And the compiler will actually now check, right? If I actually put a line in here that said, well, if instead of putting return all pos, I put return 1, the compiler is going to give me a warning. It's going to say, it's a warning because it's going to say, well, I know what you mean, but basically this is supposed to return an enumerated type. So it's one of these named constants and you just returned an integer. So you probably shouldn't be doing that. I know that in the end, enumerated types and integers actually turn into the same machine code, but you told me you were only going to use these names. So you really should only use those names. Does that make sense? Okay, so let me do a quick demo of this. Let's see, okay, I'll do this with the command line. Okay, this is the code I just showed you. Okay, and I'm using my nice, I've defined num weights to be 20 with a nice constant. I've made my enumerated type, and this is the check weights function I just showed you. And I've written a main function, which is basically a unit test, right? So my main function is making an array with 20 numbers in it. The first one is -1, then a bunch of positive ones, and then I call this check weights function, and then I print out what it gives me. Enumerated types are really integers, okay? It's just integers that I've given names to certain values. So I'm printing out the return value as an integer, right? %i. And maybe I should change that to a C-ed. Do you guys remember printf from first year? Okay, because if you get confused by that, I'm just realizing maybe I should use C-ed. Okay. So what should this return? So for this test case, these inputs, okay, read this code, check weights. What should I print out? It's like one of 3 integers. So what do you think it'll be? You haven't had a chocolate bar yet? You're trying to get one? You can guess one of 3 integers. So I have a few chocolate bars to get rid of. So go ahead. It should be has negative, right? Because the very first number is negative. Has negative is really -1, just like a synonym for it. So it's going to print out -1. So I'm going to compile it. Okay, so I'll do a make clean to make sure I'm compiling it. Do a make. Okay. Oh, I need to check my make file. Actually. Okay, so I'm going to do this. All right, let me do that again. Okay, so I made it, and now it looks fine. Okay, so I just compiled it. Compiler's happy with it, and I'm going to run it. Okay, and I got 1. Okay, so why did I get 1? 1 means all positive. So let me look at that again. Okay, so it did indeed. I'm going to run it again. This seems so confusing. Let's run that again to make sure it really does that. Printed out 1 again. Okay, so it thinks all the numbers are positive. Okay, so why did that happen? Let's look at our unit test again. Does everybody agree that it should say that there's a negative number? Should be has neg? Okay, it should be. There's a bug. The bug is not in the unit test. Okay, so look at this check weights function. There's something wrong with it. What's wrong with it? It's not doing what I would expect. I guess I didn't comment it, so I probably should do that because I didn't really give you a specification. So maybe after this I'll put in a comment. But I'm giving you a verbal specification. So yeah, there's a flaw here, but it's actually hard to see. It turns out to be kind of a difficult, not a complicated bug, but a difficult one for people to see. What do you think?
Is it missing double equals?
Yes, it's missing a double equals. So this is the bug. Okay, so it says weights of I equals 0. Okay, that's not a check if it's 0. That's actually an assignment of 0. And C and C++ allow that. In an if statement, you can just set something to some other value. So I really meant to say, is it equal to 0? But what this does is it actually takes weights of I, and weights of 0, first time through, it actually sets it equal to 0, which is what I meant. And then actually, okay, it's in an if statement. The value returned from that assignment is actually what you assigned, so it's 0. So the if statement evaluates the false, and you keep going. So it goes down here. It checks, is it less than 0? Well, it's not less than 0 anymore because I just set it to 0. So it goes through that. All the other numbers are positive, so it goes through the loop. And in fact, every single one of the other numbers is also going to set to 0. So it's going to come out at the end saying all pos. Okay? Which is very confusing. If you look at this code and you can look at it for a long time, and I've done this in code I've written where you can stare at it for a long time, not seeing that what you are sure was a double equals, you actually didn't type as a double equals. Okay, so why am I showing you this? What I just compiled with, well, let me type make again so you can see how it made the program. Okay, so this is saying G++, -G basically stores information about your function names in the program so you can debug more easily. I turned off optimization so I can debug more easily. And we're using a recent version of the C++ standard. That's what that means. And then I just give it the C++ files, and I say name the output, check numbers. So pretty normal command line to invoke G++. If I look at the make file, okay, in the make file, hashtag meets comments. So we eventually call the compiler with a bunch of options, okay? And I guess I won't show you the whole make file because it's probably too much. But basically, if I uncomment that line, comment this one out, I'm going to pass some additional flags to the compiler. And the flags I'm going to pass are warning flags. So I'm telling it, I want all the warnings, that's W all, except I'm going to turn one off. All right, so I turned one off that is kind of particularly pedantic and is sometimes annoying. Okay, so now if I do a make clean and I remake, I now get a warning, okay? So warnings are basically the compiler telling you, I understand what you mean in this code. I can interpret it by the rules of the language. I can produce an output that's executable, but I'm finding things here that are making me nervous. They're kind of dodgy coding style. So you can ignore warnings. Right? I can still run check numbers. It did compile. All right, so if I run it, it's still going to do the same thing. But the compiler gave me this additional information. And what did it say? It said, I suggest parentheses around an assignment used as truth value. And it tells me this is because if you have a warning for parentheses on, that's one of the return on all the warnings. So it tells me it's on line 9. And it highlights it's this equal sign. Okay, so this text doesn't tell me much. Like I don't want to put parentheses around it, but this line, now that's identified what looks like a weird piece of code to it, I can see that's not what I wanted, right? I should go fix that. So turning on warnings in the compiler is a good thing to do because it's telling you about dodgy code. And we've done that in your project. So you will get warnings if you write code that looks funny. And if I fix this now, the program's going to work. All right, so now that I've been pointed at this, it's pretty easy to see what to do. I change that, the warning goes away, and if I run check numbers, it now gives -1, right? So it understands it has a negative. Okay, let's make sure I'm still recording. Okay, so why did I show you that? Because warnings are useful and we don't want you to ignore them. So don't have any warnings in your code because they're not errors. You can ignore them. You will still get an output, but they are flagging potentially problematic code. Now you can look at a warning and you can go, oh, it's okay, because often it is flagging something that's not a real problem. But if you leave warnings in, what happens is pretty rapidly you go from 1 warning to 10 warnings to 100 warnings, and then no one on your team will pay any attention to them because they won't notice when they introduce, warning number 101 and it's a bad one. So the only sort of stable points are no warnings or as many warnings as you can imagine. Like there's no real in between for programs. When your program is submitted and compiled, your TA gets a little report on how it did. And one of those is how many warnings it has. So you will lose marks for every warning, and it's for your own good. It's to teach you, do not have warnings in your code. So get rid of them, okay? If you can't figure out how to get rid of the warning, post on Piazza will tell you how to get rid of it. Most are pretty easy. Most are pretty obvious how to get rid of it. Like it may be flagging a bug, in which case you really want to get rid of it. Sometimes you might go, I'm not quite sure how to get rid of this, but there's always a way to just tweak your code a bit and make it go away. Does that make sense? So again, if I go back to Altera, my policy and my whole team was 0 warnings. Okay, so all the parts of Quartus that we owned, you were not allowed to have any warnings. In fact, we killed the build if they hit it. So we wouldn't actually let them build. So we were sure they wouldn't have warnings in it because we'd stop it from compiling. The reason was because that, again, you can't have a few warnings. It rapidly goes to a ton. Nobody looks at them anymore. You have to stay at 0 warnings. The analogy that I've heard this compared to is if you have a neighborhood where there are vacant buildings and people start breaking the windows and you leave them around, pretty rapidly the neighborhood starts going downhill, right? Like people go, oh, it's okay to break things, it's okay to vandalize, and it gets worse. And it's similar one is in the park. If you go to a park and there's lots of trash around, people will litter more. But if there's no trash and people pick it up as soon as it happens, people don't litter as much. So your stable state for good code is 0 warnings. You got to get rid of them right away. Okay, another thing you should do to make your style better is group related data into classes. So here's, we are giving you information about street segments. And we could have organized that into a bunch of vectors, for example, that were like the from intersection of a street segment, the to intersection, the speed limit, the length. But that's harder to keep track of. We kind of increased your cognitive load because we've created 4 things that are intimately tied together without making it explicit. It's better for us to put those in a class or a struct. And that's what we do. We have a street segment info struct to group together these various data members, okay? And that makes it easier for you to understand them. Gives us a nice place to comment them. If we made a global variable, we'd have now 1 global variable instead of a whole bunch. In milestone 1, you're going to need a bunch of lookup structures, which are global variables. Your code will be cleaner if you group those into a structure. Okay, so your TA will be happy if you just take all your global variables, put them in a structure, call it, map cache or map data, whatever you want. You're not going to put you're just going to group the data. There's no point in putting accessors and so on this because the m1.h API is an interface. There's no point in putting another interface underneath your interface. But grouping global variables that belong together, and all the global variables you make in load map kind of do belong together. They're all created by load map, they're all destroyed by close map, and they're all used to make this M1 API faster. They're a very logical thing to group into a structure. Does that make sense? As I said, don't go too far. Like they're not a very logical thing to basically make private variables and wrap accesses around, because now you're just making layers of API on top of layers of API. Doesn't really make sense. Okay, so yeah. Okay, so the question is, when should you use a class versus a struct to group them? They are basically the same. Pick either one. In C++, a struct and a class mean exactly the same thing, except a struct, by default, everything is public. So if you put class and then the first line after it is public, it is now identically equal to a struct. If you put a struct and then you put first line after it, you put private, it's now identically equal to a class. Okay, so you can use either one. By convention, people will use struct when they're like not trying to hide the data. Because everybody knows struct is public by default. It's like, this is just a group data together. I'm not trying to hide it. I'm not trying to abstract it. That's exactly what you're doing in the milestone 1 global variables. Like, this is the implementation for your fast API. It is fundamentally tied to how you organize the global data. There's no point in trying to hide that from the API. It needs to see it all. So you should just make it public, or it's clean to make it public, so you can use a struct. Does that make sense? Okay, so I think this is my last or second last topic, defensive coding. So defensive coding is you try to let your code find bugs for you. So the most kind of widespread technique for defensive coding is to use something called assertions. Who's heard of assertions? Anybody heard of assertions in code? Okay, so assertions in code are things that you know to be true, and you're going to have the code check them as it runs. So to make that easy, C++ has a header file called assert.h. So you include that, and once you include that, you can call a function called assert. All assert does is you pass it something which should be true if your program is running correctly, and if it is true, assert does absolutely nothing. If it's ever not true, assert will kill your program and it'll print a message. So what I've done here, this is our function that basically returns the street segments attached to an intersection. So you've seen this function over and over again. In M1, we're not testing you with invalid IDs. Okay, so all the IDs of intersection that we test you with will be between 0 and the num intersections in a city -1. But you may use this function later on in milestone 2 and 3 and so on, and maybe you call it with an invalid index at some point. So maybe you want it to check. And if you call this with an invalid index, you're actually going to access out of bounds in a vector, which is going to cause memory corruption. It's going to be bad. So you might want to say, well, I want the function to check for that. I don't want it to do that. If that ever happens, tell me. And what assert will make sure you notice, because it'll basically kill the program and print an error message. So if I ever passed in let's say I passed in an ID of -1, okay? So in the caller, I'll get this kind of message. It'll tell me the name of the program, which for unit tests is test libstreetmap. It'll tell me exactly what file and line I'm at. It'll tell me I'm in this function, find street segments, and it'll tell me I failed an assertion. Okay, and it'll tell me what that assertion was. So failing an assertion means it'll print out the condition, and that condition should have been true, but it's not true. Okay, and the condition I had here was basically the intersection ID should be between 0 and the number of intersections in the city -1. So if I failed that, I had a bad intersection. Okay. This is better than a comment. So I could put a comment on this saying you should only call me within this range. It's better than nothing. But this is better than a comment because it also checks it. It documents for somebody reading the code this should be true. It also checks it when it's running and it kills the program when it's not true. Okay, so you're writing code and you're going to submit it for your various milestones. And we're performance testing your code. So this assert is pretty fast. Doesn't take much time, but it takes a little. So you might go, well, I don't want to lose any time. So when I submit, I'd like to get rid of these assertions. I want them on while I'm testing my code, but when I submit it, run it as fast as possible. That's a pretty common thing people like to do. So there's a way to do it easily. You put this line, define no debug or define end debug. above, like before, the inclusion of assert.h. Okay, so if you do that, the implementation of assert is changed and it does nothing. Okay, so it doesn't slow your program down, it will never, doesn't check anything, doesn't kill your program. Why is that useful to add before you submit something? Well, you don't want to slow it down, even a little bit perhaps. And also you might go, well, once I've submitted it, I don't get a chance to fix it if I fail some of your tests. So maybe I don't want to do any checking, extra checking. I'm just gonna, even if things start looking dodgy, just keep going. Because I may as well take a shot. Maybe the program won't crash rather than I kill it. So you can do this right before you submit your milestones. Does that make sense? And so you don't have to put in self-checking code for your milestones. If you do, if you actually use the certs or any of the other techniques we talk about, show it to your TA. It's on the rubric for sort of extra credit, right? It'll cancel out some other flaw in your code. Does that make sense? Okay, another piece of defensive coding that's a good idea. I told you that for this project, you don't need to use new and delete much. So hopefully you don't have very many pointers in your code, but you might still have some. A common source of bugs is you delete a pointer, right? So you get rid of the memory that it points to, but then later on some code tries to access it anyway. Okay, so you have code that does something like this, tries to use that pointer and set, you know, as the pointer to some structure, and it tries to set a member variable to 1. This, if I don't have this line, pointer equals null, this line of code, pointer value equals 1, will usually work, okay? Because probably the memory that you deleted is still lying around, so you'll change its value, but it's not right, okay? Because this code can stop working at any time. As soon as that memory gets reused by something, this line of code could make your program crash or could just make it go crazy. So, and the worst thing is if it actually makes it go crazy. Like it's better if it crashes, but it might not crash. If you put this line in right after you delete a pointer, you set it equal to null, the null pointer is guaranteed to crash if you try to use it to access the memory it points at. That memory is always protected. The operating system will always kill you. So, and that's what you want, right? If you have done this in your code, you would prefer to die right away, and then you'll find the bug and you'll fix it. Does that make sense? And then a more advanced technique that you probably won't do, but it's useful to know about, is you can write validators for your data structures. So, so I told you I worked for many years on Quartus. Quartus has strong validation of its data structures. So there's a whole bunch of complicated algorithms, and those algorithms do things like choose where does everything go on this chip, okay? Like a million things, and I got a couple million places I can put stuff on this chip, and I got a million things to put on the chip for this design. And the algorithms are trying to be as fast and as clever as possible, which means it's easy to get bugs in them. So once the placement algorithm is done, a verifier gets called, and it would check everything we can think of that the data structures should always satisfy. So every one of those million things that it's supposed to place should be somewhere on the chip. It shouldn't be out of bounds. If it was a register, it should be at a place that can do a register. If it's a RAM, it should be a place that can do a RAM, etc. We should never have two things on top of each other. So we check all those things, and in Quartus, they can't be turned off. The cost of a bug is quite high. Somebody could generate bad hardware, put it in the system could fail. That's really bad. So if those validity checkers ever find a problem, they kill the program with an error message because we don't want people to be able to use the output. We want a bug report. And that's true when we're in development, and it's true when it's shipped to customers. So every single compile through Quartus will check that. And we did that for all the major data structures. It actually finds a lot of bugs, and they cannot be disabled. Even developers cannot turn them off, right, by construction. So that can be a powerful technique if you can validate your data. And we tried to keep those validators essentially as simple as possible. We didn't change them very much. So once we trust them, they're unlikely to have bugs. The optimization code is complicated and constantly changing. Lots of bugs, and it gets caught right away by these validators. Okay, so I'm talking about both those. This is like a picture from that is found on the web. It's a company that would basically, you type in text that you want to put on a cake, and it will automatically print it. And it appears not to understand certain German accent characters. So someone was trying to make a cake, a happy birthday cake to Aunt Elsa. and it became confused by some of the unusual characters, and it printed HTML error messages all over the cake. I just kind of imagine Elsa being very confused about how am I supposed to debug this web page from this cake. This is probably a case where they should have had some assertion checking, and it probably would have been better to kill the program rather than just keep going and print out the cake. Okay, so let me do a quick demo of this. Okay, so let me build this code. Here we go. Okay, so this is my little milestone 1 that has only the one function working. I'm going to run it through exercise to show it is actually working. Right, we cleaned it up and refactored it a bit, but it should be working fine. Okay, and yeah, the first failure is in this directly connected. So it is working fine. Okay, I'm going to go to a bigger command prompt. Okay, do you guys remember how I get a unit test? So I want to bring over a unit test, right? Anybody remember how I get a unit test? So I just showed ece297 exercise is working for the one test I have. I don't want to run in all the other tests. I'm going to bring over a unit test and modify it. Yeah. Yeah, that's right. Except it's instead of run tester, I'm going to say debug tester. And I can't remember the exact name, so I'll say star func underscore Toronto star. Okay, and I think I got it wrong. What did I do wrong here? I think I put an extra space in here. Okay, I didn't match. Oh, I think it's not Toronto. I should do func inter. Okay. So I should probably fix that. So we basically crash if it doesn't match any tests. So that's for me to do this weekend. Should give a better error message. Okay, so it just copied over the unit test. And this is exactly what we did in milestone 4. So I can very quickly bring this up. So I know that that is in my test directory. So again, tests. And I've got this M1 func intersection, and I only want the test for the thing that works. Okay, so I'm going to get rid of it directly connected. I'm going to get rid of angle between segments. Okay, so I'm going to save that. I'm going to build it again. I'm going to run it. Okay, and the test passed. So it's good. I changed it. I did that pretty fast. Let me do that again so you can see it. So I run it, and the test passed. Actually, one thing that happened here, let me build this again. Let's see if I can get it to build. Okay, let's see if I can clean and build. Okay, so I'm going to compile this again. And why am I compiling it again? Because, okay, so I got a warning. Remember I told you shouldn't have any warnings? So this warning is actually in the unit tests. So it basically is a warning in libstreetmap test driver standard out. Okay, so it's not really my code, so I can just say I'm not going to fix that warning, but I want to show you how to fix this one. So, because this is one you might get. So it basically says I'm in, that file, line 5, and it says I'm in function main, and there's I told you that the main function for C++, you can pass in 2 numbers, the number of command line arguments and a vector or an array of character pointers that are the command line arguments. So it's complaining that I'd never use either of these parameters. Okay, so I pass them into main and I don't use either of them. It's not a bug. I can always ignore parameters, but it's saying, oh, it looks a little weird. right? You put these parameters in, maybe you wanted to use them, maybe you forgot to use them. So I'm gonna go fix this right now just to show you how to, because this is, if I was writing a function and I went, oh, I passed something in I don't need, the fix is I should just get rid of it, right? Like I shouldn't pass that in. But maybe it's a function where I plan to use that later, or I can't change the interface, right? I'm going to use it later, or someone else has defined how they're calling me, so I don't want to change how they're calling me. So what I can do, so let's open up this test driver standard out. Okay, so one solution to this is I can say I'm not using these parameters, I'll just delete them, okay? And that would be fine if I know I'm never going to use them. But let's say my plan is I want to use them sometime in the future, but I want this warning to go away because I don't want to lose style marks and I don't want it to hide bad warnings. Do you know how I can get this warning to go away without deleting these? Okay, so I'll just show you this because it's a common thing. Basically, if you comment out the name, so you keep that there's an integer, but you comment out what is the name of the variable, you're essentially telling the compiler, I still want you to pass this thing in, but I'm telling you that there's no way, like I know I'm not using it because I actually commented out its name. It's now an unnamed variable. There's no possible way I could use this. Okay, so I'm going to if I build this now, I'll get rid of the warnings. Okay, so it doesn't change the functionality of the code, but that's the way you get rid of warnings for unused parameters that you would like to retain. Okay, so I pass all the tests. I'm only running the one test that I wanted. Let's bring this up again. So I'm going to put in a test with an invalid ID. Okay, so let's say that let's just copy this. Let's change this test to pass in -1. Okay, so that's bad. I'm passing in an illegal index, so I'm going to fail this test. But actually, it could corrupt memory now. This is really bad. So let's just run it and see what happens. Okay, so I build it, run it, and it failed, but it didn't actually, it actually did have an unhandled exception. Okay, so basically it crashed. But it doesn't tell me why it crashed. And sometimes it won't crash, right? It'll just corrupt state and it'll silently go along, but your program has now gone mental, right? Bad things will happen. So let's go look at how I can put assertions in to catch this. Okay, so go back to my m1.cpp and let me get rid of this so I have a little more room. Okay, so the very first thing I do is I need to add that assertion header file. Okay, so I used angle brackets. Why do we use angle brackets for some of these headers and quotes for others? Does anybody know why you do that? Yeah. Yeah, so when you put it in angle brackets, it basically starts searching in essentially the system include files, like the things that are part of the C++ language and other key libraries that come with it. When you put quotes, it starts searching in your project. Okay, so it means the same thing, but it tells it where to look. So I put in assert.h, and then to use this, I'm going to, basically the function that I'm calling in a bad way now is this one. So I want to check, I'm passing in this intersection ID. Okay, IntelliSense is slow today. Okay, so my intersection ID should be greater than or equal to 0. And intersection ID should be less than, it shouldn't go outside this vector, right, which is dot size. Okay, and that's a statement, I just put a semicolon. Does everybody agree, you understand that? So I'm just checking, it should be between 0 and size -1. That's what I wrote. This is actually going to capture a couple of things. If I ever called this function with an invalid index, which I'm now going to do, this should catch it. Also, if I ever called this function before this vector was loaded, it should catch it. So it catches a couple different possible bugs. So I'm going to go back to my makefile tools. I'm going to build this again, run it again. Okay, so I run it. And now what it does, okay, so before I just got an unhandled exception. The program crashed. Now it basically says program test libstreetmap. I failed an assertion. Okay, so it tells me that I'm on line 61 of m1.cpp, which is right here. And it tells me that I failed that assertion. Okay, so it guarantees my program's gonna stop right away. I could now bring this up in the debugger. I could set a breakpoint there. I could examine what exactly is happening, right? What is intersection ID? How did I get here? What's going on? So it can help me find problems much faster. And I told you that, you know, you might want to turn this off when you submit. Actually, I would recommend that just to get maximum speed and because you no longer have the ability to fix things, right, while we're running the test. So you might as well go for it, even if things are looking a bit dodgy. So I put this define ndebug1, okay? It just, the C preprocessor now has this symbol ndebug set to 1, and that's going to change how assert works. And I recompile. Okay, and I run it. And now what happens is I'm back to unhandled exception. Okay, so which is what I got before I put the assert in. So the assert's not doing it anymore. So it's really easy to turn all the asserts off in your program. If your whole program's in m1.cpp, you can put that line at the top of m1.cpp. If your program has multiple files, you can make a header file that everybody includes, you know, and you can put it in that header file. So it's easy to turn on and off. Okay, so last couple of comments, and then you guys can enjoy your weekend. Okay, so I guess this is a summary of that. So work hard to keep your programs maintainable, because they're going to be modified many times. You keep the tests with the code, which is what we're doing with unit tests. You keep the documentation with the code, which is why you write comments. And another good thing to do to learn what code people can read and can't read is do code reviews. So in your team, read each other's code, give each other feedback. That's how you learn what's easy and hard to read. The rules I gave you are basically on the rubric for M1, so go look at them, make sure your code's following that. If you want a more detailed code guide, it's long, but basically this is Google's style guide for C++. So you can go read lots and lots of details on it. And if you're refactoring your code to improve style, test often, okay? So make a small change, compile, test, so that if you introduce a bug, you find it right away. Okay, thanks everybody, have a good weekend. And I don't know if you were talking about, I think I also have to go over there and talk about it. So, go ahead.